No conversation about technology is complete without talking about Intel. So we're going to give a warm welcome to Intel's Jonathan Woods. He is in charge of their Advanced Technologies Group and Intel's vision for what's next. Whether it's in the Winter Olympics or in your home, Intel is helping power mobile innovation. So, Jonathan, please come to the stage. We're pleased you're here.
Meredith, thank you. Thank you, dear. So thank you, Meredith, and thank you for the opportunity to come and talk to such an esteemed audience today. So first, a little bit of an apology, I guess. I work for a US company, and yes, I'm a Brit. So that's probably the strangest thing to do it, but we are indeed in a race. Now, I'm responsible for the partnership side aspect of the organization, and partnerships are really important. They're really important when you look at how we're going to accelerate in 5G, and today we're talking very much around about being in a race. So let's just move on to congratulate the US and congratulate the FCC in one particular area. And it's really, if we look at the frequency spectrum allocation here, we've done a great job in the US with regard to the higher frequency bands. So 28, 39 gigahertz, millimeter wave, great job. What we need to work on to build this out and scale this out, and a number of the speakers have already spoken about this today, is really concentrate on the mid-band. The 3.7 to 4.2, making good progress in identifying that, but to be really competitive and on a global scale, you really do need to have these mix of bands, and you really need to do that if you want to address all the different types of use cases. So, strategy. What is Intel's strategy when it comes to playing in 5G? A number of the speakers have talked about when they started and how they went about starting. Intel started, particularly about 2015, 2016, and identifying the next change. Intel's strategy is an end-to-end strategy. It's very important, of course, to very much focus on some of the key enablers, the wireless technology piece. And we've talked about that a lot today, and I've just talked about the spectrum side of things. But it's also a transformation across the whole network. And if Nicholas was sitting here, he'll probably be thanking me for this, as well as Michael from Nokia and Ericsson. But it really is very important. When you're looking at going 8 times faster, in the last 10 years, it's 8,000 times more data. If you look at that level of growth, you really know you need to transform your network. You're going to have to transform it both in the radio access network, need significant improvements in processing. You're going to need to bring edge compute right to the network, and you're going to need to implement that if you want to provide those low latency use cases. The spectrum itself will clearly help if you follow the specification and you implement the specification. But you really, if you want to look at an end-to-end performance, it's not just about the radio network. It really is the end-to-end to the data center, the cloud. And Intel's strategy is to look across the whole company and get all our organization focused on ensuring that we optimize both in the RAN, in the core network, and for those who don't know Intel's position in the core network, a great deal of the architecture we look today that we see in the data center is moving into the core network, being virtualized based on software-defined networks. So Intel is working very, very hard to ensure that we're solving problems across the whole of the paradigm of the end-to-end for the industry. In addition to that, of course, we're doing some cool things on devices. At the end of the day, we want cool devices, we want cool consumer devices, we want embedded enterprise use cases, and so we're doing a great job in trying to bring products to market as quickly as possible. There's going to be some challenges, particularly with the millimeter wave frequencies. So you're going to need to see a coming together of vertical groups to actually approach this and do it slightly differently in the past. So one great example of that, of what we're seeing, is where we see car OEMs and we see wireless service providers coming together and partnering with technology companies to form an association called the 5GAA. Great example of looking at a problem statement and an opportunity and bringing the right type of people together to try and figure it out. I envisage, and I hope this is the case, across all these different verticals, as we start to implement 5G, we'll have more collaboration. And that's great being the job of being in partnerships as I'm in, is I have the great job of bringing those people together and start talking and building those consortiums and building those groups. and trying it in the field. I think it's really important when it comes to getting hands dirty with any new technology is to really be out there trying it early. And again, compliments to a lot of the operators here in North America. I saw Rachel and I see Ed here as well, and a number of others, really getting in and trying to implement these services and getting them out in the field, and we see even commercial launches towards the end of this year. So partnership is very important. It's partnerships across verticals, it's partnership across wireless service providers, and it's the technology companies to come together. I want to turn to a few examples. An example of a collaboration. Okay, this is not actually in the streets here of Washington. This is in downtown Tokyo, but it's a great example. It's really solving a problem of how we use millimeter wave. This is 28 gigahertz, so it's actually very pertinent to the United States. So we see a collaboration between Nicholas's company, Ericsson, Intel, providing the core technology on the radio, Toyota, a car OEM, and also an industrial company that's focused on implementing technology in vehicles, a company called Denso. So 4 companies coming together to actually show 5G connected cars operating in a real live environment connected to a core network. And we implemented that and try multi-base station connectivity. So it's really good to be out there trying it and trying to solve problems. When it comes to devices and when it comes to end-to-end, I think you need to consider probably a couple of things. So for example, I think on some of the challenge we have of implementing 5G will be of how to find sites. It will be how to look at implement base stations in situations, environments that are a lot more denser, small cell city, smart city type of environment. On the left-hand side there, what we did, we took a city beacon, which is a digital display, and we populated that not just with a 5G connection. We also populated that with this very small, flexible base station configuration, which was connecting devices across the whole of the Mobile World Congress show here. But it was implemented within a digital beacon setup, meaning that you're really finding new creative ways to get your base stations into the environment. And also a lot more cost effective than trying to do it with the traditional base stations of the past. On the connectivity side, Intel, what we were showing here at Mobile World Congress was actually to try and bring what was an engineering challenge of trying to get millimeter wave antennas into a device and do it in a real live functional device. This particular device that we showed in February actually is the first 5G chipset that we put out in the market in 2017. We optimized it, we add millimeter wave to it, and we were connecting a PC using very low latency demonstration. And this is what we're going to see. I think one of the early category devices you'll start to see with these always connected PCs. And a number of our colleagues have talked about gaming and esports. These type of applications are perfect for this kind of category of technology. Now, this is where I get, sort of the proud moment. So a little pop quiz for everybody here. How many medals did the USA win in the Olympics? Come on, you must have get this one. All right, I know the Brits didn't win any, but well, it was 23. So congratulations, 23. We had 22, so we didn't quite 22 live 5G links up and running in Korea. We had. I think we certainly had a real network. We had it connected to 28 gigs of real. We had it cameras. We had cars. We had games. We had it of 2 locations. We really stress tested the technology to the nth degree, minus 19 degrees. And I was there at minus 19 degrees. Fortunately, I was not installing the equipment out in the real cold, but it was great. So it's starting to happen. And the only way you're really going to get it out there is to try and try these really challenging environments. So I really like to challenge the US ecosystem, the US economy. To really win this race, you need to be out there and you need to be piloting this technology as early as possible. So I'd like to finish there and leave you with that thought. Let's win the race in 5G. Thank you.